So for homework 1, you're given the assignment of measuring stop, closure duration, and voice onset time for a variety of voiceless, English voiceless oral stops in different vowel environments that is paired with different vowel qualities. And what I wanted to do was make a very quick video here where I take an example file, not something from your homework, but an example file, and show you how I would measure stop, closure duration, and VOT for those files. So I've opened up a demo file that has me saying par, tar, and car in it. And when I click View and Edit, let me bring that over here. When I click View and Edit on this, I get a sound file. I get the sound editor, it's called, in Praat. And you can see I've got please say tar. I think it's please say tar, please say, well, please say par, please say tar,
Please say par.
Mm-hmm.
Please say tar. Please say car.
Okay, and leaving aside how strangely I say the word please, notice that what we're going to be interested in here are these stop closure durations. Here is roughly the stop closure for P, it's somewhere in there. Here is roughly the stop closure for T, it's somewhere in there. And here is somewhere roughly the stop closure for the voiceless feeler stop, or K, and it's somewhere in there. And then we're interested in the voice onset time, which is the distance between those stop closures and when the vowel begins for the following word. And I'm going to fudge a little bit. Normally you would want to separate out what we'll call the release burst, and I'll show you the release burst for each of these, or at least for the first one. Normally we would want to separate that out, but I'm going to include it in the measurements of the VOT just to make the assignment a little bit more tractable. Okay, so here what I've done is I've selected in please say par, I've selected the voice onset time plus a little bit of me saying say and a little bit of the starting of par. We can hear what that sounds like. Okay, and I'm going to say view, zoom to selection, or you can hit Control N or Command N on a Windows or a Linux or Macintosh. Okay, so think about what happens during a voiceless stop. During a voiceless stop, the active articulator touches the passive articulator, and we get a complete cessation of sound. This is actually why I call it a stop. And what we're looking for then is a signature of just very low, very small deviations from the zero crossing here, right? So over here at the end, the right-hand side of these is always easiest to find. Over here on the right-hand side, we have a spot where very clearly silence stops happening and some noise begins, right? And that noise is this little bit of aperiodic noise here. This is what we would call the release burst. Okay, but I'll come back to that. A little bit harder to find is the thing that's on the left-hand side. But here's my suggestion. My suggestion is to look for the very last peak, the very last bump of the preceding vowel that has any of the characteristic vowel shape at all to it, right? So in that case, it would be this one. It's very low amplitude. The deviations from zero are quite small, but if you notice, it has its shape is of this portion of the complex wave is highly reminiscent of the complex wave that the periodic complex wave that has been repeating up until then. So what I've done here is a first order approximation of the stop closure, and if I play that, it should be, there might be some clicking at the beginning and the end, but it should be basically silence. Okay, and you hear that clicking? Almost certainly that clicking means that I've missed the zero crossing on one end or the other. What I've done is I've selected somewhere, I've drawn one of these horizontal lines through the middle of a place where, in fact, the line, the electrical signal captured by the microphone did not have zero voltage, right? So what I'm going to do is I'm going to say select, and I can move the start of the cursor to the nearest zero crossing, and Praat will then go through and find a place where there is zero energy and draw the left-hand side of my selection there. And then I can do the same thing with the right-hand side. Okay. And I will normally do that with keyboard commands. I'll normally do that with Control, comma, Control, period, or on a Macintosh it would be Command, comma, Command, period. But now I can read off the starting time, the ending time, and crucially for the homework assignment, I can read off the duration in seconds, and I need you to convert that to milliseconds for the actual assignment. And now if we listen to it, that clicking should be gone. Okay. So the question is, how long is the stop closure duration in par here? It's 185 milliseconds long. And hopefully you can see how I got that number. Now, for your own notes, for your own records, you might want to write down somewhere that you marked it starting at 1.51 in the sound file and ending at 1.69 or 1.68. The reason for that is I might ask you when I'm grading an assignment, I might say, I don't understand how you got this number. Can you show me exactly where you measured it? And that would be one way of being able to go back and show me exactly what you did. Another thing you could do is to create and annotate a text grid, but I haven't shown you how to do that. If you want to go look up online how to work with text grids, I can give you a script that will then actually extract all the measurements for you, so you wouldn't have to write down the numbers. You could just run a script, but it involves teaching yourself how to make a text grid and then using that. Okay, so here we've got the stop closure duration. That's how you get stop closure duration. Now if I want to get the VOT, I have to do basically the same thing. And what I would like you to do is remember how I figured out where this vowel ended. And the rule I came up with was we're going to mark the last periodic bit of the complex waveform that has any of the character of the preceding vowel at all. We're going to mark that as the end of the vowel. And I'd like you to follow that same rule on the other side when marking the end of VOT. And here's what I mean by that. So first of all, we should start in exactly the same place, because wherever stop closure duration ended, because we're including this release burst in our measurement of VOT, wherever stop closure duration ended, that's where our VOT measurement needs to start. Okay, so now I will select I need to select the VOT. And to do this, I'm going to change the view a little bit. I'm clicking. This is way past. I've held down the Shift key to get this selection. I've held down the Shift key and clicked over just kind of in the middle of the vowel. It's far past where I need to be. But what I would like to do is go back to the Select menu, and the View menu, and say Zoom to Selection again. So now I've zoomed in a little further. The only thing on my screen now is the release burst of our P, the aspiration, and then the start of the vowel. And you can hear what that sounds like. Yeah, pa, pa, pa. Okay, so the left-hand side we know is good. And what we're trying to find over here on the right-hand side is the left edge, the leading edge of the first bump that has the character, the acoustic character, of the complex periodic waveform that we're going to hear as the vowel, right? And if we look, that first bump is here. It has this long, tall, skinny positive bump, and then this sort of lumpy shape. And you see that repeats, and we'll learn better ways of talking about this as we go through acoustics. Then we'll see that repeats here. It's basically the same shape. It adds a little bit more detail, and then it repeats here. So where I'm going to end VOT, and I'm going to do this by holding down Shift again and clicking in approximately the right spot, I'm going to end it right there. Remember, to start the stop closure duration, I clicked on the right edge of one of these bits of repeating complex waveform, and to end VOT, I'm going to click on the left edge, right, so that I'm consistent, so that I'm always including the same kinds of complex periodic repeating information always in my stop closures and always in my VOTs, so that I end up I'm not double dipping essentially, and I'm being very consistent. And if I follow a rule like that, I've essentially written a little algorithm for myself that will hopefully make my measurements internally consistent. And since this is the way I did it, it should make your measurements match mine as closely as possible. Okay, so then I'm going to go up to the Select menu, remember, and I'm going to say move start of selection to nearest zero crossing, and do it again. Move end of selection to nearest zero crossing. That should basically sound like, there it is. Okay, and now I can read my duration off of here. Now this is my VOT for par. It would be 95 milliseconds. And the end of my measurement is 1.79. That's second 1.79 into the overall wave file. Okay, and you know what the left edge is, although it's not currently shown on the screen. The left edge was whatever you wrote down last time for the end of stop closure. It's let me zoom out a little bit. So I can just say View, zoom out, and you see it's 1.697 or 1.70. That might be slightly different. I don't remember what I had for the end of stop closure duration, but there you go. That is how to measure stop closure duration and voice onset time. And if that's all you're interested in, you can stop right now. But I wanted to do one more thing, and I'm going to say zoom out. Well, here, let's zoom to the whole thing. Show all. We'll zoom all the way back to the beginning. And I wanted to show you, I'm going to repeat the process with a little bit less talky-talky. I'm going to repeat the process now for tar. Okay, so select roughly the area, zoom to selection. See, we've got this repeating vowel thing here. It's easiest to find the end of the stop closure duration. I'm going to zoom in a little bit further. Okay, so I'm going to say that that's the end. Zoom out. And notice you'll be going back and forth when you're doing this. Control comma, control period. That moves the start and end to the nearest zero crossings. And this stop closure duration is 318 milliseconds long. It starts at second 4.55 of the sound file, ends at second 4.87. And I would write all those things down in my notes, but in the actual box on my answer sheet for this stop closure duration, I would write in this number. And you don't need to include any decimal places in the milliseconds. We don't have that kind of precision here, right? All right. So then I need the VOT. Zoom to selection. Beginning of the selection. I'm in a little bit far here. This is closer in than I'd like to be, so I'll zoom out. Now I'll zoom to selection. Yeah, I'm going to change this right-hand side to right there. Control comma, control period. I can read off 111 milliseconds for VOT. I'll zoom out again. I can write down in my logs, in my notes, exactly where I took that measurement. Zoom out. You have separate files, right? So you won't be zooming back to show all and then zooming back in on the different words, but you get the idea. So zoom to selection. Here's my stop closure. Somewhere in there, roughly. So I'm going to select very, very roughly and say view, zoom to selection. Looks like right there is the end. All right, now this is the kind of thing I was hoping to see. You see, there's this noise out down here at the end, and then there's what is clearly a release burst. What's going on here? Think about what might be going on here, right? So let me not tell you right away, but let's play this. Right. What could be happening? Think about the difference between a P and a T and a K. What could this noise in here be? Right, so I'm going to zoom way in, zoom to this selection. What could that noise be? There's some noise before. This is the obvious release burst. This is where I have used pulmonic pressure to push air out of my stop closure. This part right here, this is why plosives get called plosives, right? But what is this? Well, it's literally some mess happening in the vocal tract. It's some noise happening as I prepare my vocal tract to start saying the K. It's probably not part of my K. In fact, it's probably not contributing to your percept of a K there at all. So even though there's some noise here, even though there's some stuff going on, I wouldn't want to end my stop closure duration right there. I wouldn't want to end it right there. I wouldn't even want to end it right there. I would want to end my stop closure duration here where the release burst happens, right? As far over as necessary to get all of the stop closure that doesn't include the release burst and nothing more and nothing less. So let me zoom out again. Oops. It's really a very long stop closure. Comma, period. I've got my measurement now. I can double check this by zooming back into selection, and I will often do that. I will sort of zoom in, zoom out. There, I've got my stop closure duration. It looks pretty good. It starts at second 7.22 in the file that ends at 7.60, and it's 375 milliseconds long. That's my stop closure duration. And then how long is my VOT? Well, that one's actually a little bit more straightforward in this sound file. I'm going to come over here, and it will include this little bump but it won't include this this periodic thing that happens. So let me zoom out a little, and you can see. So I've included up to the left edge. It looks a little funny. I can show you. I didn't include any of that periodic bit of complex waveform. Zoom out again. Up to the left edge of the first one of these big bumps of the vowel. And if I read off my measurement, that's 109. We'd round up here, 109 milliseconds, and I'd write in my notes that this is where I got it from. Okay, so that's measuring stop closure duration and VOT in voiceless stops in English, aspirated voiceless stops. I hope this has been useful. I will tell you that if I were doing this myself, and when I did this to make the answer key, I would use text grids. You don't have to use text grids. I'm not going to teach you how to use text grids yet, but that's how I would do it, just in the interest of full disclosure. Thanks.